There are trends with all this. There are trends with more capacitors push the resonance frequency in one direction, fewer capacitors push it in a different direction. The amount of inductance of the source has an effect on this. So let's take a look at these trends so we can kind of see how the system is going to behave. This system right here, I have a case where I have a short circuit power of 30 MVA. Short circuit power. You divide out the voltage, square root of 3, and the mega, and that's short circuit current. So 30 MVA. We have a two-step capacitor bank right here. Step 1 is 600 kVar. Step 2 is also 600 kVar. So we have two 600 kVar steps. Let's take a look at what happens. When the first step comes online, using our approximation for parallel resonance, we take the short circuit MVA, 30 MVA, divide by the megavar rating of the capacitor, 0.6 megavar. Take the square root, raising it to the 1/2 is the square root. And this shows us that the resonance would be approximately at the 7th harmonic. If we were to add the second step online, that would be the equivalent of 1200 kVar or 1.2 megavar. So with the second step online, 1200 kVar, 1.2 megavar, the resonance would shift. It would go down to the 5th harmonic. So what this shows us is the more capacitors that go online, the lower the resonance frequency shifts. The strength of the source also has a big impact on this. So let's say that we have a single 600 kVar capacitor online, and the source is 30 MVA. The short circuit current, voltage, square root of 3, we have 30 MVA for the source power. The resonance, 30 divided by 0.6, take the square root, 7th harmonic. But, and this is a big problem, what if the utility company makes some changes? What if the utility decides to take part of their substation out of service? Maybe they have two transformers, and they take one out of service, and their short circuit MVA drops. It goes from 30 MVA to 15 MVA, and you have no idea that they did this. How does that impact the resonance? It impacts it pretty significantly. If the short circuit power from the utility drops, now we have 15 MVA divided by 0.6, take the square root, it drops to the 5th harmonic. And so as the utility system or the source becomes weaker, less short circuit current, the resonance tends to shift lower.